class of 24 students threw a cricket ball at sports. The distance thrown by each student was measured in meters. The results are shown below. Okay, so let me write down the now we've been given a table. Okay, so let me draw the table. Okay, now you have dashes in the table, so you need to fill this dash, you need to fill this dash, and then you need to fill this dash. Okay, now the question is how far we can go. Go back to the data given and locate the largest value that you can see. What is the largest entry you can see? I can see a 60 here, but is 60 the largest value? No, 60 is not the largest value. Look at the largest value. So there is one large value, 63, and then is there any other value? No, 63 is the largest value, but the values given from the table are 20 to 29, 30 to 39. So what I'm going to do, I'm going to stretch it from 40 to 49 and then 50 to 59, and I have to include 63. This is the largest entry, right? So this entry is going to be 60 to 69. Okay, fair enough. Now the frequencies given here are 3 and 5. Now what you need to do is between 40 to 49, look at all values. How many people have actually thrown the cricket ball to a distance that is lying between 40 and 49. So 40 included. So what I'm going to do, 40 to 49, so you have 1 year, you have 2 year, and then 3, 40 to 49, 4 and 5 and 6 and 7 and 40 to 49. Is that all? See, there is 40 to 49. This is also included. Okay, so you have to be very cautious in spotting the values. So how many are there? 1, 2, 3, 4, 5, 6, 7, 8. And apparently I'm getting 9. Is it 30? Oh no, okay, the 30, 39. Let me check the entries. Okay, no, this is not included. This is 63. We did not, we circled this for showing that this is the maximum value. So this is not included in the count. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. So 8 are there. So you place 8. Next 50 to 59. So you will have to again locate the count 50 to 59. So you got 1 there, 2, 3, 4, and 5. Anything you see here? There's one over hiding here. 6. So 6 entries are there. You got to write the 6 entries. 60 to 69. Clearly, I know there are only 2 entries. So this and this. So this is the frequency. So after you have completed the frequency and this distance table, you have to go to the lower bound. Lower bound, you see, actually you need to go 0.5 units before 20. So that's going to be 19.5. That's going to be my lower bound. Okay. It's called as a lower class bound or lower class boundary. Now for upper, see, anything 0.5 units above this 29, that will be on the upper bound. So what am I trying to show here is I am approximating the entries, but there will be a situation where something like this turns up. So where will I include it? Should I include it in this interval or in this interval? So I will have to include it in this interval. So that is the understanding. So this is going to be 29.5, this is going to be 39.5, this is going to be 49.5, and this is going to be 59.5. Okay, fair enough. So we have got the bound, lower class bound. Now for this is going to be 39.5, 49.5, 59.5 and 69.5. Okay, so that is the completion for this table, all important table. Okay, now clearly we know sigma f. What is sigma f? Sigma f is already given to be as 24, so we can just state that there. Now they are asking us to draw the histogram. So the histogram, what we have to do for the histogram is we will have to have 20, 30, 40, 50, 60 and one more interval, that is the end point will be 70. So 20, 30, 40, 50, 60. So these will be the boundary points when we are drawing the histogram. So that's exactly what we're going to do. So I'm going to draw the axis. So this is the axis that we have to draw. Now this is the distance in meters and this is the number of students number. Okay, so we start here as 0 and this is going to be 10 units, this is 20, this is 30, this is 40, this is 50, this is 60 and this is 70. Now 20 to 29, okay, 20 to 29, how many students are there? 3 students are there. So we start at 20. So suppose this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, probably one more, 10. Okay, so each of these are a unit. Now since it is the space is restricted, the x-axis we have to draw the scale. Okay, the scale according to the question, the scale says you take 2 cm. 2 cm is equal to 10 meters. Okay, this is the x-axis. And y-axis you take 2 cm. Okay, same 2 cm. 2 cm to be equal to 1 unit. Now you will have to visualize that each of them are 2 cm, right? So this is one student, actually, not only one student. It does not matter because this count is going to be student count. Okay, so in this case you can just place the student. So 2 cm is equal to 1 student. So understand that each of this is 2 cm. But of course we are just going to name or number the values as students. So 1 student here, 2, 3, 4, 5, 6, 7, 8, 9 and so on and so forth. Okay, the all important part comes here in drawing the histogram. So this is all standard. No matter what you place, the values counts. Okay, the distance, because this is not a graphical function where we are more particular about the intersection. This is just a straightforward bar chart, or I would say histogram. So the points in this case would be between 20 and 29 we cannot draw, right? So we have to stretch it to 30. So between 20 and 30, how many students are there? So between 20 and 30, we have 3 students. Okay, so you just draw that block between 20 and 30. In 20 and 30 you have 3 students. Okay, now between 30 and 40, The 30 and 40, how many students are there? 30 and 40, you have 5 students. So 30 and 40, you should join them. You should not keep them isolated. So 30 and 40 histograms, you have to connect them. So that is done. Between 40 and 50, how many students are there? Each student between 40 and 50. So 7 and 8 between 40 and 50. Right? 8 students. And then between 50 and 60, how many students are there? Between 50 and 60, you have 6 students. Right there. And between 60 and 70, how many students are there? 2 students. Between 60 and 70, you have 2 students. Okay, so that is the completion for this beautiful question. So histogram is successfully completed. Okay, so having got that, now the next question is the number of students who threw the ball. Let me write that. The number of students. This is a question. Okay, we need to find the number of students who threw the ball. A distance of 50 meters or more. Okay, so 50 meters or more, right? So 50 meters or more. So who are the people who have actually crossed 50 meters and more? So there are already 6 students who have crossed 50 meters. And that is one statistics, right? Because 50 meters and more comes over here. That is one statistics. Now the next statistics you have to observe here is somebody who is throwing 60 and above. That is also should be counted, right? 50 meters and above is the question. So 50 people who have crossed 50 are 6 in number, but there are also people who are throwing something in the range of 60 and 70. So you need to take that into account. So that is going to be 2 there. So the solution here is 6 students plus 2, which is equal to 8 students. The number of students who threw the ball a distance of 50 meters or more. It is because of this more, the 2 is coming into the frame. Okay, so that is the solution. Now the next question is find the probability. Let me write this down. Find the question number 2. Find the probability that a student chosen at random threw a ball a distance recorded as 50 meters or more. So you pick one student from here. You have to get that probability, that the chance of landing up a student who have crossed 50 and more. So it is the measure, right? So what is probability? Probability is nothing but that measure, that chance. So let me write that. So there are question is wants us what is the chance of locating a student from the group of 24 students who has thrown a distance of 50 or above, right? So we are getting this probability. So probability of a student throwing 50 meters or above is equal to favorable case divided by exhaustive case. So favorable is 8, total case exhaustive is 24, which is 1 over 3. Now probability always will include a percentage, so you multiply by 100. So that means 100 divided by 3, so 33.33%. So the likelihood of getting a student is 33.33% chance. Okay, so that is the conclusion for that particular question.